this video we're going to have a look at quadratic sequences. There are two types of question for this. So the first question we're going to have a look at is where you've got to find the next term in the sequence. So to begin with, we work out the first difference. This one we can see we've increased by 3, then we've increased by 5, then we've increased by 7, then we've increased by 9, and so on. In quadratic sequences, we always have to work out our second difference. So that's the difference of the differences. So here we've gone from 3 to 5, so we've added 2. 5 to 7 is 2 as well. 7 to 9 is 2, and so on. This second difference has to be the same for it to be a quadratic sequence. It wants us to find the next term. So we now know that we need to add 15 to our previous term. 51 plus 15 is equal to 66. Having a look at part B in the question, it tells you that the nth term of a different quadratic sequence is 2n squared plus 5, and it tells you that it wants you to work out the sixth term. So here we need to replace that n with 6. So we know that 2n squared means 2 times n, which in this case is 6 because we're working out the sixth term. We need to square that and add 5. Now we just complete this calculation remembering our order of operations. So we need to work out our 6 squared first. So this is 36. Then we complete our multiplication. So that's equal to 72 plus 5, which then equals to 77. Question 2. Pause the video now and have a go at this question. Right, so again we work out our first difference. Here we're increasing by 6, then we're increasing by 10, then we've increased by 14, and then we've increased by 18. So again we can work out our second difference. This has to be the same in a quadratic sequence. So we're increasing by 4. So we now know we'd need to increase our last term by 22 to find our next term. 50 plus 22 equals to 72. In part B, we again replace the n with 5. We then work out 5 squared, that's equal to 25. Then we complete our multiplication. 3 times 25 is 75. Subtract the 10, we get 65. That's our final answer. So here in question 3, it's asked us to find an expression in terms of n for the nth term of this quadratic sequence. So, just like in the previous questions, we need to work out our first difference to begin with. Now we work out our second difference. Here we can see we're increasing by 2 on our second difference. So our next step now, I always start by rewriting the original sequence at the top of my exam page. Now we have to look at the second difference. This is plus 2. We need to half that second difference and put it in front of n squared. So half of 2 is 1, and we put it in front of n squared. So now we need to write out our 1n squared sequence. So this is our n squared sequence multiplied by 1. So if we put n as 1, 1 squared is 1, n is 2, 2 squared is 4, n is 3, 3 squared is 9, n is 4, 4 squared is 16, n is 5, 5 squared is 25. We now need to subtract our original sequence, that's the one I've written in purple, and we take it away from our 1n squared sequence. So we look at our first term. 1 take away 1 is 0. We then look at our second terms. 3 subtract 4 is negative 1. We then look at our third terms. 7 take away 9 is negative 2. We look at our fourth terms. We get negative 3. And then finally 21 subtract 25 gives us negative 4. What we're left with here is a linear sequence. So we just need to work out the nth term of this linear sequence. So now you can check out my nth term of a linear sequence video if you don't know how to do this. First step is to work out what your difference is. Here we can see that we are decreasing by 1 each time. So that number goes in front of n in our linear sequence. We now write out our negative 1 times table. Our final step now is to see how we need to match on our negative 1n sequence onto our original sequence. So how we go from negative 1 to 0. Well, we add 1. Now we can compare our second term. We've gone from negative 2 to negative 1. So we need to add 1 to that as well. We can check with our third term. Negative 3 plus 1 gives us negative 2. So therefore, the nth term of our sequence here would be negative 1n add 1. Our final step now is to piece the two answers together. So we had 1n squared minus 1n plus 1. Pause the video now if you'd like to have a go at this before I go through it. Here, just like before, we work out our first difference. We've increased by 7, we've increased by 11, we've increased by 15, and here we've finally increased by 19. We can then work out our second difference. We're adding 4 each time. So now I'm going to write out my original sequence. And this is the bit we need to remember. We take our second difference and we half it and put it in front of n squared. So half of 4 is 2 and we put it in front of n squared. Now we think of our n squared sequence and we remember we've got to times it by 2. That's what 2n squared is. So when n is 1, we'd get 1 squared, which is 1, multiplied by 2, which is 2. When we put n as 2, we get 2 squared, which is 4, multiplied by 2, which is 8. When n is 3, 3 squared is 9, multiplied by 2 is 18. 4 squared, 16, multiplied by 2 is 32. And then finally, 5 squared is 25, multiplied by 2 gives you 50. What we now need to do is subtract our original sequence from our 2n squared sequence. And we do this term by term. 4 subtract 2 is 2. 11 subtract 8 is 3. 22 subtract 18 is 4. 37 subtract 32 is 5. And 56 subtract 50 is 6. Okay, so now we've got to find out the nth term of this linear sequence. To begin with, we find out the difference between each term. Here you can see we're adding 1 each time. Therefore, our 1 goes in front of our n. We can now write out our 1 times table. Now we've got to see how we match on our 1n sequence to the sequence above. So we can see on our first term, in our 1n sequence it's 1, but in the sequence above it's 2. So we're exactly 1 away. If we check this with the second term, again you can see you're 1 away. With the third term, we're again 1 away. Therefore, the nth term of this sequence here would be 1n plus 1. So now to finish off the question, we put our two pieces together. We had 2n squared plus 1n plus 1.